Today we will solve the problem 5.6 of Griffiths third edition Introduction to Quantum Mechanics. The problem 5.6 is imagine two non-interacting particles and each of mass m in the infinite square well. If one of the state psi n equation 2.28 and the other state is psi of L psi L, where L is not equal to n, calculate the expectation value of x minus x1 minus x2, uh, x1 minus x2 whole square, assuming first part A is they are distinguishable particle, P they are identical boson, C they are identical fermion. So we have to solve this thing. So the from equation 2.27, the wave function we know is a well-known wave function for infinite square well potential. Psi of x is equal to a sine kx, where ka is equal to 0 plus or minus pi plus or minus 2 pi plus or minus 3 pi. It will go on. In this section A, we have to calculate if the particle are distinguishable. So, if the particle are distinguishable, x1 minus x2, expectation value of x1 minus x2 whole square is equal to expectation value of x squared A, this is particle A, plus the expectation value of the square of the expectation value of the particle P minus 2 times the square of the square expectation value of A and the expectation value of P. So you can realize that if particle are distinguishable, you can see A and P are not the same state. So this equation is you can easily verify this equation. If A and P are equal, then you will get different expression. So now we will solve the A. Before going into the detail, please refer my earlier lecture, Solution to Griffith Problem 2.4. Uh, I have given the link in the description box. The expectation value of x is equal to a by 2 from this problem. That also related to infinite square well potential. And the expectation value of x squared is equal to a square 1 over 3 minus 1 over 2 n into pi whole square. So now you apply this into this expression. That is first section 1 is we are taking that particle are distinguishable. We can distinguish between the particle A and B. So for that formula is given. That expression is I have given it in the introduction itself. The x1 minus x2 whole square, expectation value of x1 minus x2 whole square is equal to the expectation value of x square of particle A and plus the expectation value of x square of particle P minus the expectation value of x of particle A and x of particle P. Now you substitute this here. So the x square of particle A is, let us say A is at nth state, then it will be 1 over 3 minus 1 divided by 2 n pi whole square. Then for particle P, we are taking that A square 1 over 3 minus 1 over 2 m pi whole square. That is the particle P is at mth state. Then the expectation value of x is a by 2 into a by 2. Here you have 1, 2. So here this 2, 2 will get cancelled. So last term is a squared by 2. So now you can take all the term contain a squared, so you can take a squared outside. Then here you have 1 by 3, here another 1 by 3. This will become 2 by 3. Then next term minus 1 over minus 1 over 2 pi squared n squared. And here you can see minus 1 over 2 pi squared m squared. Of course, we have this here of because we have taken a squared as common, so 1 over 2. Now, if you subtract 1 over 2 from 2 by 3, that is, if you subtract these two, then naturally you will get 1 over 6. Then here you have 1 over 2 pi squared as a common factor for second and third term. So you take 1 over 2 pi squared as a common factor. Then this will become within the bracket. So this is 1 over n squared minus we have taken out. And this will become plus because we have taken minus outside. So this is 1 plus n squared plus 1 plus m squared. Just now we have seen the expectation value of x minus x1 minus x2 whole square for distinguishable particle. Now we are going to see same for the identical boson and fermion. In section P, we are going to see it for identical boson. This is for boson. This is sorry, 1 minute. This is identical boson. So section P is boson. The general expression is given in Griffith 5.25, equation 5.25. Here you can see the expectation value of x1 minus x2 whole squared is equal to the expectation value of x squared of particle A, x squared of particle P minus 2 expect 2 times the expectation value of x for particle A and x for particle P. Here you can see one extra term minus or plus 2 times the expectation value of particle A and B whole square. So this we have seen. This is first three term is for distinguishable particle. Just now we have seen this value in section A. Now our aim is we have to find this one. First, you have to find the expectation value of x of A and B. Then you can square it. So this expectation value of mn is equal to 2 pi a integral x between a to a 0 to a x sine m pi divided by a x and sine n pi divided by a by x dx. This is for wave function for the particle A. This is for particle B. This is normalization constant. Here you can see sine A sine P format. It is in sine A sine P format. So you know very well the sine A sin P is equal to 1 over 2 cos A minus P minus cos A plus P. So this 1 over 2, I'm cancelling these 2 and these 2. So this will become 1 over A x cos a minus p, that is m minus n pi divided by a x, and minus cos a plus p, m plus n pi divided by a x dx. Now we can find the first integral. First, there are two integral. You will take the first one now. Then we can find for the second integral. Here I am taking only integral. Later we will multiply this by 1 over a. So this integral is integral between 0 to a. I am labeling this as I1. This is I1. So I1 is equal to integral between 0 to a x cos px. Here the entire thing I am taking as p. That is p is equal to m minus n pi divided by a. So I am taking that as p. So x cos px dx. Uh, General solution for this integral is x over p sin px plus 1 over p squared cos px. So this I have taken. Of course, we have to apply the limit 0 to a. Now we will find the answer for this. We have found the value of integral 1 I1 is equal to x over p sin px plus 1 over p squared cos px. Apply the limit 0 to a. First you apply the limit a. If you apply the limit a, what will happen here? P value is we have taken p is equal to m minus n pi over a. If x is equal to a, let us say x is equal to a, then this a will get cancelled. So this will become m minus n pi. Whatever may be the pi value, whether it is pi or 2 pi, 3 pi, this will be 0. So this term will get cancelled. This is going to be 0. Only this term exists 1 over p square. Here p squared is equal to 1 over p squared is a squared divided by m minus n whole squared pi squared. Here I am taking this as now we have applied the upper limit. Of course, here this p is m minus n pi. When you apply a, this a will get cancelled. So this is just cos m minus n pi. Then you apply the lower limit. So in the lower limit also sin 0 0, no problem. Then cos 0 is plus 1. So this will be minus because we are applying lower limit. This will be minus 1. Here, the cos m minus n or m plus n pi is equal to minus 1 whole power m plus 1, m plus n, m plus n. Because if m minus n is odd number, this is minus 1. If it is m minus n is even, this is plus 1. So that is sin cos 0 1, cos pi is minus 1, cos 2 pi is plus 1 again. So this will become alternatively. If it is even number, it is plus 1. Odd number, it is minus 1. So that is the meaning of this. So I am going to write cos m minus n pi as minus 1 power m plus n, and this minus 1. So this can be written as a squared minus 1 m plus n minus 1 divided by m minus n whole squared pi squared. So then we have seen this x mn expectation value of x of mn first particle a and b is equal to integral 1 over 2 0 integral 0 to a. That is this is 1 over 2 we are taking outside. Integral 0 to a x cos m minus n pi divided by a x minus cos m plus n pi divided by a x. This is the total integral. So we have seen the value for the first integral. So this integral value for the first integral. So which is equal to here you have a squared times minus 1 whole power m plus n and minus 1 this one and m minus n whole squared pi squared. What about this? You can easily identify that whether cos m minus 1 m minus n pi is minus 1 power m plus n. Similarly, cos m plus n also m plus n pi also same thing. Because it depends only whether it is odd or even. M minus 1 is even, then it is 1. M plus 1 also even if it is plus 1. Otherwise, it is minus 1. So, this is for m plus n or m minus n. We can take minus 1 whole power m plus n. So, this will become a squared minus 1 power m plus n minus 1 divided by there is a difference because here it is uh, m plus n. This is not m minus. Here it is m minus n. Here it is m plus n. M plus n whole square pi square. So now you take this a square out. In both the term, we have a squared. So we can cancel this a and this a squared simply will become a. Here also like this, a simply a. So you can take here in both term you have pi squared as common. So you can take a pi squared, here also a pi squared as common, and this also common, minus 1 power m plus n minus 1. So minus 1 m plus n minus 1 also common I have taken out. So here only difference is the first term contain 1 over m minus n whole square and second term m plus n whole square. So this will reduce to this. Then we will now our next task is we have to square it. Now we got this result. We are going to simplify the terms inside the bracket. So if you take LCM, this will be denominator will be m minus n whole square multiplied by m plus n whole square. So naturally, here in the numerator, you will get m plus n square minus here m minus n square here because the cross product. So m plus n square minus m minus n square. Here, you know very well that a plus, that is, we can say uh, a plus p whole square minus a minus p whole square is equal to 4ab. So I'm writing in the numerator. This is 4mn using this relation. A plus p whole square minus a minus p whole square is equal to 4ab. Now what I am going to do is this m minus n I'm whole square I am going to take m minus n into m minus n. See here n minus n, m minus n. Similarly, m plus n whole square, I am going to take m plus n, m plus n. For mathematical reason, I have written this alternatively. So then, what is this m minus n? This m plus n. You know very well that a minus p into a plus p is equal to a squared minus p squared. So a squared minus b squared can be written as a minus b into a plus b. So this is equal to m squared minus n squared. So same thing is this. So if you multiply these two, you will get whole square. So this will become 4mn minus m squared minus n squared whole square. So I have taken denominator using this fact. So now what will happen to this? There are two possible interest result. That is, if n plus n is even, then this will be you will get if it is even number, then you will get minus 1 square power 2 or 4 or 6, it will become plus 1, plus 1 minus 1 will become 0. If it is even number, m plus n is even, then it will be 0. When it will be even, when both m and n are odd parity, or both m and n are even parity. Both are even number or both are odd number. If you add two odd number, you will get even number. So if both are even or both are odd, you will get to plus 1. So the result will be 0. That is, if m and n have same parity. That is either it may be odd parity or even parity. If it is opposite parity, say m is odd and n is even, if you add both, you will get odd parity only. This will become minus 1. So minus 1, you will get minus 2. So this will become minus 8mn divided by m squared minus n squared whole squared. Of course, you have a divided by pi square. This is if m and n have opposite parity. Opposite parity, we mean that one will be odd parity, another one is even parity. Now we will see the complete result. Now we have seen already that the expectation value of x1 minus x2 whole squared is equal to the expectation value of square of x squared of particle A, x squared of particle B minus the expectation value of x for particle A and particle B minus or plus 2 times the expectation value of x AB for particle A and B modulo square of this one. So now in section A, we have seen for distinguishable particle, you will get only this term. So these three. And only thing is new is last term, minus or plus. This negative minus is for boson. So for boson, it is minus. Boson, it is negative. So we have seen just now that the expectation value of x for A and B. We have seen this, and you just square it and you multiply this by 2. So if you square it, what you will get? 8 squared will pick up 64. Then 64 into 2 is 128. So 128 times it is a squared, uh, m squared, n squared, and this one. Pi squared will become pi by power 4, and m squared minus n squared whole thing power 4. So this is for boson. And what about fermion, identical fermion? Section C. Only thing is this minus will become plus here. You can see. Sorry, this negative sign will become plus here. So everything is the same. Thank you very much for watching my video and supporting me continuously. Thank you very much.